In this video, I'll go over an example of using composite materials in Scan&Solve Pro. I'll teach you a few handy tips for preparing your model in Rhino. But first, let me tell you a little bit about composites and how Scan&Solve Pro handles them. Orthotropic materials, such as composites, have different material properties in each direction. To apply an orthotropic material to a component in Scan&Solve, you must define two material directions: the fiber direction, defined by the red arrow, and the thickness direction, defined by the blue arrow. This can be done with either the Specify or Guide option. Use the Specify option when the fiber direction does not change within the component. Flat surfaces, like the flat fins, base, top, and sides of this model, can be added using the Specify option. If the fiber direction changes throughout the component, as with curved features, the Guide option must be used. These curved portions of the side must be added using the Guide option. Scan&Solve Pro does not yet support selection of a polysurface to be a guide surface, also known as a tooling surface. Knowing this, we must split the border into 8 components. The first step in preparing the model is to split features into valid components that can be added. Let's begin by hiding everything but the sides. To separate this single polysurface, use the Explode command. Prompt the command, select the polysurface, and hit Enter. This explodes the polysurface into separate surfaces. We now need to reconstruct 8 polysurfaces, 4 straight sides and 4 corner pieces. Prompt the Join command and select the 4 straight surfaces on one side. Hit Enter to join the selected surfaces. The joined surfaces do not yet make up a closed polysurface. Select the polysurface and prompt the Cap command to close the ends. To verify that the surface is now a closed polysurface, prompt the Show Edges command. Select the polysurface and hit Enter. Verify that there are no naked edges. In a similar way, create 7 more closed polysurfaces. Once you have split the side into 8 components, the next step is to create guide curves and surfaces for the corner pieces. Recall that the Guide option must be used to apply an orthotropic material to a curved component. We'll need guide curves and surfaces to use the Guide option on the corner curved pieces. The fiber direction is defined by the guide curve, and the thickness direction is defined by the surface normal of the guide surface. Let's start by creating the guide surface. An easy way to create a guide surface is by using the Extract Surface command. Select the surface on the curved polysurface that you wish to extract. Ensure that the Copy option is set to Yes. You can move the new surface up or down, but ensure it remains parallel with the original surface. You now have a guide surface separate from your closed polysurface. Next, let's make the guide curve. The Duplicate Edge command creates a curve by copying a surface edge. Select the curve on the surface and hit Enter. We now have a guide curve and surface for this corner component. I find it helpful to add a new layer to put all the guides in. This way you can hide the guide curves and surfaces when you don't need them. Create guide curves and surfaces for the remaining 3 corners. Once you have created all necessary guides, you can start adding the composite components in Scan&Solve Pro. Click the Add button to add a component. Let's start by adding one of the straight sides of the border. Under Orthotropic, select Carbon Epoxy Quasi-Isotropic as the material type. Recall that the Specify option can be used for straight components. First, select the origin of the orthotropic coordinate system. Then specify the longitudinal direction, and lastly, the thickness direction. Click Apply, and then Add to add a curved corner component. Select the same material, but this time we'll use the Guide option. Select the guide curve. Then select the guide surface. Add the remaining red components, making sure to use the Guide and Specify options when appropriate. Another component that needs to be added is the honeycomb core. Composite sandwich structures, such as this one, are made up of 3 components: 2 flat composite pieces and a honeycomb core. Sometimes the honeycomb core has similar material properties in each direction and can be modeled using an isotropic material, but oftentimes they are orthotropic since they are stiffer in the thickness direction. For this core, I previously added a new custom orthotropic material. As before, the Specify option can be used to define the orthotropic coordinate system. Lastly, add the blue components as steel AISI 304. The next step is to check that you have selected the correct material directions for each component. Scan&Solve Pro displays a coordinate system defining the material directions for the composite. The red axis defines the fiber direction. The green axis defines the perpendicular direction to the fibers, and the blue axis defines the thickness direction of the composite. To display the coordinate system on the model, go to Settings, then check Material CSYS Display. Coordinate systems will be displayed on the added components. You can check each component to ensure you applied the material correctly with the Specify or Guide option. Now you're ready to add loads and restraints and run a simulation. I applied restraints to the knobs on the back steel pieces and applied a 1000 Newton scalar force to each of the front flat steel pieces. These conditions produce the following results. Notice the deformation appears correct, and the locations of max stress are also consistent with what you'd expect. Thanks for watching. If you'd like to try out Scan&Solve Pro, or if you have other questions or comments, please visit intacsolutions.com.